Hi, this is Mrs. Pone, and in this screencast, we're going to look at something called formal charge. And we looked at charges in terms of ions earlier in the year, cations and anions. But formal charge relates to covalent molecules. And when atoms are sharing electrons in order to achieve an octet, sometimes atoms are going to be surrounded by double bonds or triple bonds. Formal charge is going to kind of look at the atom in terms of the charge that's surrounding it. And there is a fancy or complicated way of writing this formula. Formal charge equals V minus parentheses N plus B over 2. And there is a way to simplify this formula. Formal charge is equal to the valence electrons in a neutral atom. How many valence electrons would an atom have if it were neutral? And you just look at the column number on a periodic table. Then after you draw your structure, you're going to look at the number of unshared valence electrons. So this is the Lewis structure for water. And if we were to look at this, let's try to write the formal charge of oxygen. And let's kind of, how many valence electrons are in a neutral atom of oxygen? Well, oxygen is in column 6. That usually has 6 valence electrons. 6 minus unshared valence electrons. After you draw the Lewis structure, how many electrons in water are unshared? Well, there's 2 here and 2 here. So 6 minus parentheses 4 plus half of the shared electrons. Remember, each one of these bonds is 2 electrons. So how many electrons is oxygen sharing? Well, 4. And what is half of the amount of sharing? What's half of 4? B over 2. What is half? It's 2. 4 plus 2. So 6 minus 4 plus 2 is going to equal 0. So the formal charge on oxygen is 0 in this case. We can do the same thing with hydrogen. How many valence electrons are there in a neutral atom of hydrogen? Well, there's 1. And we can subtract from it. How many unshared? Well, there's no unshared valence electrons. It doesn't have any. 0. And half of the shared electrons? Well, this oxygen is sharing 2 electrons. And half of that is 1. 0 plus 1. 1 minus 1 equals 0. So this oxygen has a formal charge of 0, and this oxygen is the exact same thing. It's a symmetrical molecule, so this has a formal charge of 0. So the charge on each is 0. And that's really how we calculate formal charge, and we'll do a few more examples to make sure you are comfortable with it. And that shows that there if you're watching the PowerPoint instead of the slideshow. If you want to go back and look at the PowerPoint later, the answers are going to be on there. And the answer's here as well, but I'm going to do this out. Let's do the formal charge. Let's start with the oxygens. Valence electrons in a neutral atom of oxygen. 6. And this is symmetrical, so it's going to be the same for each case. Each oxygen is going to have 6 valence electrons. How many unshared valence electrons are there? Well, each oxygen has 4 unshared electrons, 2 electron pairs. So 6 minus 4 plus. And how many electrons is this oxygen sharing with this carbon? Well, each one of these bonds represents 2. So it's sharing 4 electrons. Half of that is 2. And we've got a parenthesis here. 6 minus 4 plus 2 in the parentheses. Again, it equals 0. Formal charge on oxygen in both cases is 0. Carbon. Carbon normally has 4 valence electrons. 4 minus. How many unshared valence electrons are around carbon? 0. There's no dots around carbon. We don't have any dots there. And how many total electrons is carbon sharing? Well, it's sharing 1, 2, 3, 4 over here. 4 more over here. So carbon is sharing 8 electrons, and if we cut that in half, that becomes a 4. 4 minus 4 equals 0, so the formal charge is 0. And let's look at NH3. And this is ammonia, formal charge. In this case, we see it's going to come out 0 again. We can do all the hydrogens in one shot because hydrogens, it's symmetrical. It's all connected by a single bond. There's no difference between them. Valence electrons in a neutral atom of hydrogen, 1. Column 1A, 1 valence electron. Unshared electrons, there aren't any. 1 minus 0. plus half of the shared electron. Each hydrogen is sharing 2 electrons with nitrogen. And half of the number of shared electrons is going to be 1. 1 minus 0 plus 1 is 0. So formal charge is 0. 0. And again, the formal charge of nitrogen. Nitrogen has 5 valence electrons. It's in column 5A. How many unshared valence electrons are there? Well, it has 2 unshared valence electrons. So 5 minus 2. And how many electrons in total are half the shared electrons? It's sharing 1, 2, 3, 4, 5, 6, because there's 3 bonds. And we cut that in half. So that becomes 3. Another way to look at it is you can see, the number of bonds. Instead of half the shared electrons, you could also just take the number of bonds, whatever's simpler. 5 minus 3 plus 2 equals 0. So formal charge is 0. And it's not always going to be 0 for everything, so don't think that it is. We're going to see some cases where it's not, and where it's going to be very useful to look at the formal charge, especially for something like, say, sulfuric acid. Notice here we have some formal charges that are not 0. So let's do this one out. And again, notice that we have a single bond here, a single bond here. So the formal charge on both of these oxygens will be the same, but this oxygen has a double bond. So we can't assume it's going to be the same as these. We're actually going to have to do it out. And I guess over here I started with the oxygens on the top, so we can do that. Oxygen normally has 6 valence electrons. Minus how many unshared electrons are there? 1, 2, 3, 4. Half of the number of bonds, or half the shared electrons. There's 2 bonds, so this number is going to be 2, or you could say half the shared electrons. 4 shared electrons, half of that is 2, and that equals 0. So the formal charge here is 0. Now let's do the oxygens on the bottom, and these are symmetrical, single bonds, so they will be the same. Oxygen has 6 valence electrons, minus how many unshared valence electrons are there? Well, each one has 6 unshared valence electrons, plus half the number of shared electrons, or the total number of bonds. There's 1 bond, so 1 is going to be there, or there's 2 electrons here, half of that is 1. 6 plus 1 is 7. 6 minus 7 is a plus 1. Or actually, 6 minus 7 is a negative 1. Sorry. So each oxygen is going to be a minus 1. So we have a 0, a minus 1, and a minus 1. And I'll give you a hint. The formal charge on a polyatomic ion, all of the atoms, they must add up to whatever this is out here. So nitrogen is going to be a plus 1 to cancel with one of these, leaving only the negative 1. So, but let's do nitrogen out. Nitrogen has 5 valence electrons. Valence electrons in the atom, minus how many unshared electrons are there? Well, nitrogen doesn't have any unshared electrons. Plus the total number, or half the shared electrons. There's 1, 2, 3, 4 bonds. So I know that's going to be 4. Or if you wanted to count them out, 1, 2, 3, 4, 5, 6, 7, 8. 8 over 2 is 4. 5 minus 4 is 1. So plus 1. And that's how we look at formal charge. And the formal charge of these kind of cancels out. And this molecule is left with a minus 1 overall. So that's formal charge. Not too bad if you have the formula and you look at it and you understand valence electrons. So you have an assignment, and it's a double part assignment. I actually pre-drew the Lewis structures for the last molecules. You're going to draw the Lewis structure diagrams for these 4 molecules. And then I want to know the formal charge of each atom in them. And make sure, again, that the formal charge on all of these atoms, it cancels to the point where it's going to be negative 1. Because when you have a polyatomic ion, it should do that. And this 3 should be a subscript. That should be ClO3. This is Mr. Spohn. Hopefully you can calculate formal charge now. I'm out.